Alright. Today we are going to start taking a look at angles, okay? Just kind of the real basic ideas about angles. The quizzes are not completely graded yet, okay? Hopefully by tomorrow we can get them back to you, and we'll talk about a few of the commonly missed ones on the quiz, okay? But for today, we're just going to start talking about angles. Alright? Now, I know you guys have worked with angles a little bit before. You've probably seen things like acute, right, and obtuse, okay, those types of definitions. We're going to look at some of those today, maybe some new, some old things. First thing is just our definition of an angle, okay? Our definition of an angle is two non-collinear rays that have a common endpoint, okay? There's kind of a lot to unpack in that definition right there. Okay? So first, what is non-collinear? Right? Points that are not on the same line. Right? So we're saying non-collinear rays. So rays that aren't on the same line. Well, what's a ray? What is it? Exactly. Right? A line that goes on forever in one direction. So let's actually jot that down here. Okay? A definition for a ray. Okay? A line that goes on forever or extends forever in just one direction. So what we're saying here is that an angle is when two rays come together, right, and they meet at an endpoint. Okay, that forms an angle. The rays, then, we say are the sides of an angle. To name a ray, okay, so if I wanted to name the sides of this angle, the first one, ray AB, it's going to be really similar to how we named a line. I'm going to choose 2 points and draw a line over top. Okay, this is a slight difference though. If I want to name this ray, I'm going to call it AB and draw a line over top with one arrow. Okay, for a line, we drew 2 arrows. Right? For a ray, we're just going to show that we have 1 arrow going forever in one direction. Now, there's another small difference. Okay, for a line, we said it didn't matter the order you wrote the points, right? We could have called this AB or BA. For a ray, the order does matter. Okay, for a ray, we always write the vertex first. Okay, when we're naming a ray, write the vertex first. Okay, and the vertex is that point at the end. Okay. So how would I name this side of the angle? So a vertex, when we're talking about an angle, a vertex is the point at the end, basically, right? The point where the two rays meet. Okay. So how would I name the other side of this angle here? AC with a line over top with 1 arrow. Okay. Questions so far? All right, so let's talk about naming angles then. Okay. There are multiple ways to name an angle, but the key is to figure out where the vertex is. Okay. So if I'm looking at this angle, the vertex is point A, right? The point where the two rays meet, okay? The point in the middle of the angle. I can name an angle just using the vertex. So one example that I could use is to just call this angle A. I could also call it angle BAC. Now, the key here, okay, and this is more common, using 3 letters to name an angle. The key here is that whenever we're naming an angle, the vertex goes in the middle. Okay, the vertex goes in the middle when I'm naming an angle. So it might be a good idea to jot that down. Just got to push down a line. Okay, so yeah, we could call this angle BAC, or we could call it CAB, right? Just as long as the vertex is in the middle. What's that? we'll get there in a second. Okay, so when we're naming an angle, a couple of ways to do it, right? We can either just use the vertex and say this is angle A, or more commonly, we use 3 letters to name an angle. Okay, but the key is that whenever we're naming it, the vertex goes in the middle of those 3 letters. So we could call this angle BAC or CAV. Right? Now, another less common way is if we have a number inside of the angle, we could just call it angle, whatever that number is. So we could call this one angle 1. Okay? Questions so far? Now actually let's go to example 1 before we do write acute and obtuse. So in example 1 down here, okay, we've got this diagram where there's a bunch of different angles pictured. So A just says name every angle that has R as a vertex. Now, in that last example, we said you could name an angle just by the vertex, right? So we call that one angle A up there. What if I just say angle R down here? We have no idea what angle we're talking about, right? So in a diagram where there are multiple angles, I have to use 3 letters to name the angle. I can't just say angle R. You see 4 of them? All right, give me one of them. Angle SRP. That would work. And so we're saying R is the vertex, right? So R goes in the middle when we're naming it. So that's TRP. Angle TRP. Sure. That's a good one. What else do we have? TRQ. Yep, that works. Alright, angle TRQ. What else? PRQ. Yep. What else? PRT. Yep. What else? Great. QRP. So we actually already named that one. Right? PRQ and QRP are actually the same angle. So it's TRP and PRT. Did I do that one? Yeah. Oh yeah, you're right. Yep. So we already named that one as well. Alright, so far we have SRP, TRP, TRQ, and PRQ. SRQ. Yeah. We still need that one. What else, Sebastian? Would SRP be one? Yes, it would. Right? Angle SRT. Even though that is a straight line, that still fits our definition. Right? Our definition was 2 rays that share an endpoint. So that is still an angle. Amen? So we've got other names here, right? We've got angles 1, 2, and 3, but technically we already named each of those, right? So SRP is the same thing as angle 1, right? So I mean, we could, say, well, this is the same as angle 1. PRQ is the same as angle 2, and then TRQ, that's the same thing as angle 3. Okay? But we would not have to name them both ways, okay? If you just put one of them down, that's all right. Right? Yeah, we'll get there. You keep jumping ahead. All right, so are we okay with naming angles up here? Yes. All right, so then in B here, we want to name the sides of angle 1. Okay, so angle 1 is up here. How would I name the 2 sides of this angle? Could I have said SR instead? No, right? Order does matter when we're naming a ray. We always put the end point first, and then another point on the ray. So what's the other one? RP. And order does matter. Okay so far? Alright, so let's jump back up here, okay, to this sentence right here where we're talking about right, acute, and obtuse. Okay, and there are blanks to fill in on your paper. Okay, I have them written up here on mine. Okay, but a right angle is an angle whose measure is exactly 90 degrees. Okay, so make sure you jot these down in the blanks on your notes. An acute angle is less than 90. And an obtuse angle is greater than 90, but less than 180. Okay? When you did write acute and obtuse before, you may not have had this part on the definition, right? Specifying that it has to be less than 180 degrees. We just know an acute angle is smaller than 90, right is 90, obtuse is greater than 90, but it also has to be less than 180. Okay, we'll look at angles this year, okay, and measures of arcs and different things that can be greater than 180 degrees. Okay? So, if we look at example 2 over here, okay, we just want to kind of classify each of these angles. So, angle ABD. Okay, so we need to figure out where that is first of all. Right? Well, angle ABD is going to be this angle right here. Does that appear to be acute, right, or obtuse? Acute, right?
It's a cute little angle.
Yes. Acute little angle. Acute little angle is less than 90. So then the second part of this says, use a protractor to measure. We're not going to use a protractor. We're just going to kind of estimate what we think it looks like. So this angle here, if we were to estimate, how many degrees do you think that angle would measure? What's that? No, we're still doing this one. So, what does that measure look like? 65, 45? What are we? 40? 45? 52 and a half. All right. I actually think that angle looks kind of smaller than a lot of your estimates. I would say it's less than 45 degrees. I'd probably say somewhere between 30 and 40. Well, so remember, okay, we're starting here. It's not starting at ground level, right? So if we were to measure just this piece, right, we're not saying this piece extends down here. We're just saying this piece right here. Okay, I would probably say that that's, I don't know, we'd say 35, 40 degrees, something like that, I think would be a good estimate for this one. Okay, so remember, just because ray BD here is kind of close to BE that's going straight up and down, that doesn't necessarily mean it's close to 90, right? We're still, this piece, AB, is slanted up. So to look at that angle, I'd say it's probably a little less than 45 degrees. How about angle DBC? So DBC is going to be obtuse, right? That's this angle right here. And what do we think a good estimate for that one would be?
130.
120? Yeah. What did you say, Lindsay? 130? Yeah. Right. So this would be 90 degrees, so it's that much more than 90 degrees. So 115, 120, maybe even 130, somewhere in there, I think would be a good estimate. All right, so let's we'll say 120 degrees. All right. How about the last one, angle EBC?
Right angle.
That is right, and yes, all right angles are 90 degrees. Questions? All right, let's jump down to the exercises then. Okay, we're going to take a few minutes. Sure. Yeah, so here, I'll scroll back up. So that was just a right angle is 90, cubed is less than 90. Greater than 90. Yep. All right, so let's take a few minutes here, and you guys try the exercises down at the bottom. Okay, in numbers 1 through 3, you're looking at the first diagram and naming angles and sides. In the second one, you're classifying as acute, right, or obtuse. So the sides are so first, what's the vertex?
That's the rundown right there. Yeah.
So it's not that shit. Sides.
Where you go to work today? Where you go to work today? He's going there around 5, and he's getting all the tables and chairs out for us. So all we gotta do is scrub. Yeah, because we probably have some better things. Oh, I don't care. It's still more hours. Right now we have 12.5 hours. They're $25. Well, so sad. It's $125. Me, it's $137.50.
Because the vertex is in the middle. So you guys look, you remember
We'll
to
probably work from
BBC.
6 to 10 tonight.
So
That's 4 hours.
So
16 and a half. 11. I would have 181. You would have 165. Mr. Fach, I don't get number 2.
Okay, so the vertex.
So naming the sides.
So when we look
So,
at the BBC for number 2,
Scroll down here.
there you see it.
So
Yeah, so another name for
BBC.
Now it's changed to BBC.
This angle right here,
See.
right? And BBC. So to name the sides, first we want to start at the vertex.
Yeah.
Vertex would be Z, right? And then, well, so D would be the sides, and D, C.
Oh, okay, now I get it. So these ones right here?
Yeah.
Vertex. It's not B, it's D. Right? Yeah. For number 4. B.
Yeah, you're right. Yeah, it would be big.
And then BBC for another name for BBC.
So angle, so for that one,
You got BBC.
so that angle right there, okay? So the key is that
Just like a tab at the top.
this is the vertex, right? That has to be the point. So So what?
So it'd be CBD.
Exactly. Right. Exactly.
Drink so much water. Bro, I was really gonna come to your house. Yeah, I was gonna hang out with you. Okay. You're like, I'm going to school.
All right. It looks like we're about done here. So let's take a look at these together. All right. For number one. Number one, the vertex of angle 4. So angle 4 would be that angle. So the vertex is B, right? Just point B, right? We're not saying angle B. We're just saying the vertex is a point. So point B. The size then of angle BDC. So angle BDC is going to be this angle here. So same again. So close.
Look at me.
So DB and DC. Right? So the vertex is at point D, right? So order does matter when I'm naming the sides. So I have to start at the vertex and say DB and DC. Right? You said DB.
I said DB.
Okay. Alright. Then the last one. Okay, another name for angle DBC. So angle DBC is right here. Angle 3, that would work. Angle 2 would not work. Okay, so angle 3 is naming this angle here. What would be another way to name it? Angle 4 would not work. What was it? CBD? Angle CBD would work.
Wait, why you
Got one of them? Alright. So I could have said angle 3 to name this angle here, or I could have reversed the order of the letters. But what matters is that B is still in the middle. Okay, the vertex always has to stay in the middle. Okay. Questions on those ones? Alright, then in our second set of examples, okay, we are just classifying each angle as right, acute, or
Guys, there's
obtuse.
way too much talking.
First one, angle MPR. It looks obtuse, right? MPR would be this angle here. So that looks like it's greater than 90. How about RPN? RPN looks like a 90-degree angle, right? So right. And then angle NPS. So NPS right there looks less than 90. Right? So acute. Questions? Awesome. Must be butter. What
Geometry.
classes? Mostly sophomore. You're a very keen observer. No questions? All right. let's. Do we want to do some of the back and have more time to practice tomorrow? Or just let them more separate lesson?
No, wait a minute. You want to give me more homework?
Well, we've got